Sound test. Check. 1, 2, 3. 1, 2, 3. Everybody looking at me on a test. Gotta make him with the best. Gotta hit him with the vest. Hit him in the chest. Put him to rest. All right, yeah. Sound check's good, Jared. Sounds good, buddy. All right, guys. Welcome to episode 49 of the Swift and SwiftUI Learnalong. I am your host, Oat. You can call me Oat. Just call me Oat. And quit distracting me, dude. What do you? Oh, right. For the uninitiated, quick intro. This is the stream where I call it. I am learning things in real time, strictly on stream. So everything that we've covered in terms of the content has been on stream. There's no, off-stream learning. So it's not like I'm learning something and then trying to present it to you as a form of entertainment, but rather more a cathartic experience, a long-lived experience, and sometimes very painful, simply because you are watching me learn in real time, and hopefully by narrating the entirety of the courses and the literature that I'm using to learn, others can learn along with me. But that is the important thing to understand here, because, well, not all streams are like that. So I want to point out that fact that you are not learning from me, you're learning with me, to the extent that the core material is not my own. I am simply narrating it and going through the course in real time and opening that up for people to watch. Now, I will insert my isms and whatever thoughts that I have, and take it for what it's worth. If it's not for you, then get the hell out. But if you find it valuable, and I hope that you do, that is what this is. So we've already gone through the Swift portion of its namesake, so Swift and SwiftUI. We've completed the Big Nerd Ranch Guide on Swift. So that was the first. It was a book, very good book that I highly recommend. Swift Programming, the Big Nerd Ranch Guide, 7th edition. It was a great book. Highly recommend it. That has all been streamed. So we covered the entirety of the Swift programming language itself. Now we've moved into a course called the SwiftUI Compendium. So if you want to go to iosfoundations.com, this is not my course. Again, I don't no affiliate links for you. Sorry, brother, can't scam you. Okay, I'm not one of those yet. But seriously, come check this out. It's been a nice course, but obviously you will also see the contents here. To some extent, this is still fair use because I'm adding all this shit on top of it, but it is what it is, and I don't think it really takes away any value. I think this is so far it's proven to be a great, valuable course and will be a good reference to look back at anyway. So teaching us a lot of good, valuable information, not only strictly about SwiftUI, but also how to navigate the Apple documentation, which is also a very important skill to have. So we're working our way through that. After we're done, I forgot I made a little mini, little shitty, little flow chart here. Okay, yeah, now you can look at something while I talk. Okay, so this is step 1, right? We've gone through Swift, Big Nerd Ranch Guide, and down here you can see the YouTube channel. If it might be on Twitch and X, I don't know that all of them are. I'm just pointing out the YouTube channel. If you want to go back and watch those recorded streams, they're all on that YouTube channel if you want to get caught up. And at some point we will edit all of the streams. I'm about a quarter of the way through, since Jared can't seem to figure out the whatever his excuse was. But so that will be up eventually. But it's easy enough to see the sections because I'm on the stream. I constantly have the book up, so you can see when I'm actively working in code. You can just fast forward through all the other bullshit, and then in the description of each video, I put the starting point for each book, so it's pretty easy to know, what we're covering for that stint. But anyway, and actually, if anybody wants to volunteer, or not volunteer, but wants to do the editing work, send me a DM, and I would be happy to pay you for your services if you're interested in doing that. And it should be pretty easy. I just want stuff chopped out. It doesn't have to be neat and pretty. But yeah, if anyone's interested in that, hit me up, brother. Now, step 2, this is where we are currently. So we're covering SwiftUI. So now we're actually doing the, the fun part of the quote unquote fun part, although Swift was a lot of fun to learn in general. But this is where we'll learn how to write actual user interfaces, make stuff appear on screen and all that shit. So this is where we are currently. And I don't know, I don't know, maybe, gosh, I actually don't know how many sections there are. So I'm just going to guess that we're maybe 15% of the way through, just because we haven't even started on the example project yet. So more to come from SwiftUI. After we're done here, we're going to move to step 3, which my little note here, 1 to 2 days. I don't want to spend too much time on this, but I do want to lay some groundwork. So for my application, which I didn't get to this part, but part of this stream is in an effort to build an actual product that I intend to sell, on the open market as an iOS app and an iPad OS app and a Mac OS app initially, and then eventually a web app. But I want to use this to build it first, so that's why I chose Swift, or partially why I chose Swift, for the platform specificity. But also, as part of that, the application is going to have a SQLite database, so local onboard storage, where we're going to load data into. So we're going to design that schema to an extent. Well, we're going to use tools to design it, because that shit's painful to do manually. But you'll get to see what that looks like, what that process looks like. And then we're also going to set up a GraphQL API. I've had some experience with GraphQL just with hobby projects, so I'm excited to, really to see if it is still viable. I don't know, it seems to kind of be falling off in terms of developers that tend to reach for it at first glance, but I enjoyed it. I like the schema aspect, and I like the whole notion of being able to represent schemas in a way that makes perfect sense to the front end, and then on the back end you can just do whatever you need to do. That resonates with me. I like that a lot, as opposed to the typical JSON based APIs and how those work. So we're going to try GraphQL, and we won't spend too much time there, but we'll get the schema set up and take a look at that process. And then after that, we're going to hit the books again. Coming back to the books, another big nerd ranch guide, but this time it's going to be on iOS programming, which is technically, it's really on, like I said, iPad OS, Mac OS, but this is a book that's going to focus on Apple's APIs, their frameworks. So we're going to learn more about those, since that's predominantly what we'll be using. So I think that'd be a good thing to do last, because right after this, we're going to just start building the thing. So this is going to be my application, MRP Panda. Got the domain name already. Got that locked in, baby, and got my LLC rolling, me and wifey. So this is what we're going to do. We're going to build MRP Panda on stream. And we'll probably start to mix in at some point, because it's not going to be smooth sailing. But at some point, I do want to work in either C or Odin. Happy for any feedback or opinions on which one I should pursue. But just like we've done the Swift stream, we've stepped through that. I'll find some kind of course or book that I think is palatable, I'll say, because these are a lot different to me. I don't know. These are they're so low level. It's really different. I'll probably end up doing C. I can't do it. I was going to go ahead and erase Odin, but I can't do that to Odin. But honestly, I should probably learn C, just because Odin itself, the only downside to Odin is there's no specification yet, but I know Ginger Bill, that's the author. I'm not making fun of him, by the way. That's what he prefers to be called, is Ginger Bill. So he's awesome. But he created this, right? But he himself said, don't hold your breath. The language is complete, but there's just not a written spec yet, and therefore there's not going to be a lot of, actually I don't think there's any material outside of the tutorial and other YouTube channels that have done walkthroughs of Odin. But I don't want to sit here and watch, I understand this sounds funny to say, but or perhaps counterintuitive, but I don't like watching videos to learn things. At one point I did, even so it's kind of goofy me saying, hey, come watch my stream, which is watching a video to learn. But hey, we're all different. But there was a time when I consumed a lot of videos and it was helpful. But whatever, that is just what it is. So yeah, more than likely we're going to look at a C learning course, mainly because Odin will probably be pretty easy to learn if we know C anyway. And there's a lot of interop, excuse me, a lot of interop with C anyway. So more than likely that's what we'll end up doing, but it'll be one of the two, maybe both. And from there, we'll see, but that is quite a long ways out. So I'm trying to get as much content out before I start my new job, which is July 1st. Yeah, so at some point I will have to slow down a little bit, but for now, it's guns a-blazing. So with all that out of the way, we can hop back into where we were yesterday, and just get it cracking, you know what I mean? All right, so let's see if oh my gosh, I didn't end up going to check out other Macs. I meant to look at that, but I'm just gonna suck it up for now. I just can't fathom buying yet another machine. But oh, one thing before I get started, I've heard there's a lot circulating about this recall feature. If y'all haven't seen this, Microsoft recall. Effectively, it's this feature that is going to exist in what they are calling Copilot PCs. It's a feature called recall, and it's more or less taking screenshots of literally everything that you're doing every couple of seconds, and while you're logged into your machine, you're going to be able to, so through deep learning, machine learning, they're able to take these screenshots, right? The program will take that image data, put it into a searchable database, a vector database, and you'll be able to search while you're logged in all of your history, all of it. Literally everything you're doing, your passwords, all your nudes, your stream keys, anything would be searchable. Now, there was a lot of backlash about this. People are freaking out. Okay, but I just want to point out two things. You don't have to buy a Copilot PC. This is not inherent to Windows. It's not going to just appear in Windows. Okay? You have to have a special, there's a Snapdragon, Qualcomm, whatever chip that this needs to work. So it's not, if you have a machine right now on Windows, you don't have to worry about it. Okay? So first of all, you don't need to freak out. Just don't go buy one of these machines. Okay? That's the first solution. Don't buy it. Second of all, they already said that it's going to be opt-in by default, not opt-out, which means that when you buy it, even if you bought one of these machines and turned it on, the recall feature wouldn't be on by default. That's what opt-in is. You have to optionally choose to use it. Those are the two things. So just remember that. But the main thing is, if you don't want to use it, don't buy a Copilot PC. Wow, whoa, brother. Okay, all right, I just had to get that out because you hear a lot of just ridiculous shit. Now, and the problem is people are like, oh, well, guess I'm moving to Linux. No, you're fucking not. Have you ever tried to use Linux for work, for real work? Get the fuck out of here. I've tried many a time. And I have a Linux box. I actually like Ubuntu, the desktop experience. But yeah, you're not going to be able to do real work on it. The problem is like anything relating to the GPU really. Like gaming is it's gotten a little better, but there's still way too many issues. You have to do way too much tinkering. The average person, like I'm not full neck beard, you know, see, it's not all the way to down my neck, but I do have a beard. So I like to do some tinkering, but I'm not what you would call a Gandalf neckbeard that likes to tinker in the command line all day just to get my fucking GPU driver to be able to display HDMI. And I mean, it's really kind of wild, and you should expect to sync as a I'm being generous here. You should expect to sink at least 25 to 30 hours into configuring your machine just to get it to the point where it just works in the fashion that you would expect a Windows machine to just turn it on, or even Mac, turn it on and plug shit in and it just works. There's a lot of stuff that we take for granted. Bluetooth, audio, video, webcams. A lot of manufacturers still don't support Linux, so there's a lot of stuff that we don't realize that we just take for granted. So you're not fucking moving to Linux. Get out of here. You're just not. So just relax. Okay. All right. So now that I got that off my chest, we can get back to it. All right. So we left off on section 3.2, using forms to style a whole screen without providing layout info. Man, I need some water. I think I liked these switched, matter of fact. Yeah, swap. All right, so what did... Damn it, sorry. Frog in my throat. What did we cover yesterday? Let me go back just one item to catch my bearings here. 3. Let me see what 3.1 was. Creating the model data to feed. Yeah, let's look in here. Yeah. Creating the model data feed SwiftUI. My bad. I was getting distracted by a text message. All right, nearly every app interface operates on data. We looked at the... yeah. Okay. It's coming back to me now. Okay. I mean, I remember it, and I don't know. I do and I don't. I guess maybe it didn't really hit that well, but let's just jump into it and we'll see. There was one takeaway from yesterday that I wanted to review, but yeah, it's lost on me currently. All right, using forms to style a whole screen without providing layout information. In the previous module, I emphasized avoiding using basic SwiftUI types such as text and image combined with stacks solely as a last resort for view layout. Let me clarify. It is not that these essential elements should never be used in your apps. They are frequently necessary. However, the point is to explore better alternatives first rather than immediately resorting to the most straightforward layout constructs provided by the framework. Okay. And matter of fact, we went through this too, so I think we... Xcode tools. Oh wait, actually this was the example I wanted to see. Okay, so we'll just start here. Yeah, so they gave us this personal info, and this is a custom view. So this is what we could implement ourselves using SwiftUI. So this is a struct, which is what they recommend over a class by default. So we're saying this is a value type since it's a struct, personal information. This colon view says it conforms to the view protocol, the Swift view protocol. Then we have a constant, and then we have the body, which is the requirement from the view protocol. The sum view indicates that it's an opaque type, we learned, which basically just means it's like a generic. So if you wrote a function one with a little pokey syntax, that's the generic. So it's similar to that in the sense that any concrete type can go in its place, except, oh, I have the disappearing ink on. Son of a bee. Oh well. Except some view adds the restraint that the type that you use in place of T has to be conforms to the view protocol. And so through stacking these restraints, we're able to use that some keyword with protocols to effectively have to edit less code. So at the top level, you wouldn't have to change this even if the underlying types were to change, because as long as it conforms to the view protocol, you know that it can interact with your code even if the implementation details change. So that's what he was showing us here. Then we have these three views, label. So these are singular views with nested text views. And then labeled content is a view builder, hence the body here. So whenever we wrap, like in this case, if we wrap all of these text views, so here we're just building a string, text plus. So when we use the addition operator on strings, that's just like if you ever used Excel, concat, it's concatenating the string. So we're just building a string here, and then this formatter, or sorry, not formatter, this modifier, that dot notation applies to, since it's attached to the end of the scope here, it would apply to all of the content inside, oh sorry, not that far here. It would apply to all of the content inside the wrapped object. And so the text alignment is the modifier, and then this is the parameter. So we're saying trailing. So trailing is, in SwiftUI, trailing is the same as saying write justify. And then preview, we learned this is just for Xcode. So if we throw in that hash preview command in Xcode, anything that we wrap in it will get an immediate preview directly in the editor, which is what is shown. Well, it's paused right now, but down at the bottom, that's where we're getting that preview. So that's what this is here. And so they suggested doing this over building your own implementation for simple, previews like this. Now back to the code sample, all of this code that we're looking at creates this view. And so you see the text here is the trailing is right justified. If it was left justified, they call it leading. That would be left, and I think centered is centered. So that's pretty much the same as what most folks know to be that term. Okay, I prefer typing code as it's faster. Now wait, we read this, fixing code issues. Oh, that's right. Oh, yeah, okay, now I remember. We saw the markdown inside of Xcode, which was awesome. Let's go look at that real quick, just as a reminder. One of these files we added some, hopefully I saved it. Yeah, right here. So here, if you have, well, the way they showed us, if we click on, say, content view, this is something that we define. So control click and add documentation. I'm not going to click it because it just adds this for you. But inside of these triple backslashes, if you use these, you can write markdown. So all of this weird syntax, the pound, if you don't know what markdown is, it's a markup language for formatting. It's not a programming language, just a markup language, kind of like HTML, but simpler. Markdown is awesome. So this single hash is for the header, so you can see how it's kind of formatted. If you do a single dash and a space, that'll give you a bullet. So once we actually, we write all of this markdown, and then if we call, show quick help now, and now we have a nicely little formatted thing. So this is the same stuff that I wrote up here, but it gets nicely formatted. So the single hash space is a header 1, 2 hashes is header 2, then the dash, that's where the bullets come from. The triple backticks, you can make code blocks, so that's where the select all from table is coming from. So yeah, I mean, if you don't know, it'd probably take you less than an hour to learn the basics of Markdown. So if you don't know what it is or don't use it, but work or headed to soon work in a professional space, I would recommend using it because it's been a big help in my career. And honestly, it's been around forever, but most people just don't know what it is. So if you pull this out, blah, whip that out, suddenly, you know, now you're Mr. Big Dick or whatever you got packing. You know what I mean? But yeah, it's a good skill to learn. So highly recommend learning the basics, at least, of Markdown. It'll benefit you, I promise. Okay, now anyway, getting off the soapbox here. Let's go back to, let me get rid of that, matter of fact. Get back to this. Actually, I don't think we, yeah, I think this is exactly where we were. We'll just start here. All right. Forms offer standard layout and styling out of the box. There's much to unpack in the code snippet above. Let's proceed systematically. The notable aspect here is the absence of color or layout specifications. Consulting the picking container views for your content article reveals that SwiftUI offers numerous containers beyond simple stacks. Okay, so per his instructions, him being this guy's course, we should pop over and now read this and then come back to it. So on the top here, this is official Apple Docs. So he's describing things to us and then also recommending the official documentation that describes what he's describing to us. So I like this approach. It's really good. All right, SwiftUI provides a range of container views that group and repeat views. Use some containers purely for structure and layout, like stack views, lazy stack views, and grid views. Okay. Let me just make a quick little note over here off to the side. So strictly structure and layout. So stack views, which would be the H, V, and Z. And well, plus lazy versions of those. And grid view. I guess I gotta put that down here. And grid. Yeah, that's better. Make it smaller. I just want to be able to get back to it at some point. How about there? Because I realize even though we've been taking notes, or I've been taking notes. Oh shit! God damn it! I forgot to turn it off. Yeah, even though I've been taking notes, I realize some of it's a little too disjointed, so it's gonna make it harder on myself. When I go back to consolidate, if I don't take a little more time to organize them now, structure and layout only would be stack and grids. That's good enough. I know what that means. Okay. Use others like list and forms to also adopt system standard visuals and interactivity. Okay. All right, so we'll call this and list and where'd it go? Forms. Okay. Choosing the most appropriate container views for each part of your app's user interface is an important skill to learn. It helps you with everything from positioning two views next to each other to creating complex layouts with hundreds of elements. Group collections of views. Stack views are the most primitive layout container available in SwiftUI. Use stacks to group collections of views into horizontal or vertical lines, or to stack them on top of one another. Right, because we learned the H stack, the V stack, and the Z stack, among others. Like lazy H stack, all the lazy versions too. They don't actually render anything. They're only for grouping and organizing other views. So there is some disparity there between the view types. So there's ones that are in charge of grouping other views, and then there's just straight up views that are more like HTML elements that have their own graphical representation, irregardless of whether you wrap anything inside of them or not. H stack, Z stack, V stack don't have, or they won't render anything without other views inside of them. All right, use HStack to lay out views in a horizontal line, VStack to position views in a vertical line, and ZStack to layer views one on top of another. Then combine stack views to compose more complex layouts. These three kind of stacks, along with their alignment and spacing properties, view modifiers, and spacers, and spacer views combine to allow extensive layout flexibility. So I'm going to punch in so you can see, is this in the right? Yeah, there we go. Yep, so on the left, finished product. On the right, we see everything that builds that particular view. So the two text rows are the little gray lines, and those are wrapped inside of a vertical stack, which would mean that, oh no, wait, they're not scrollable, I don't think, but it tells us further down. But either way, so the two text elements are wrapped inside a vertical stack. So each of these boxes here, and then the horizontal stack is wrapping the vertical stack. These are layered above the image, and then a Z stack behind it so that you can layer the entire. So really a Z stack went down first, then the image, horizontal stack, vertical stack inside it, and the two text records inside the virtual stack. And then our spacer. So we learned the spacer will inherently just expand to fill out the open space, the available space. So anything that you don't fill in inside the container, in this case, the container is the H stack. And so since the horizontal stack only covered, about half, the spacer will expand and it'll apply a default set of margins, but you can also change that. So pretty good level of control. And I've said it before, I'll keep saying it probably a million times. It's very similar to HTML and CSS. So if you're familiar with that, you'll probably catch on to this pretty quick. But all right, you often use stack views as building blocks inside other container views. For example, a list typically contains stack views, with which you lay out views inside each row. For more information on stack views to lay out views, see building layouts with stack views. Pretty sure we read that yesterday, but let's see. This, oh no, wait. We're not supposed to click off. Yeah, okay, so we'll refrain from that. Repeat views or groups of views. You can also use HStack, VStack, lazy HStack, and lazy VStack to repeat views or groups of views. Place a stack view inside a scroll view so your content can expand beyond the bounds of its container. Users can simultaneously scroll horizontally, vertically, or in both directions. Yep. Stacked views and lazy stacks have similar functionality, and they may feel interchangeable, but they each have strengths in different situations. Stacked views load their child views all at once, making layout fast and reliable because the system knows the size and shape of every subview as it loads them. Lazy stacks trade some degree of layout correctness for performance because the system only calculates the geometry for subviews as they become visible. Yeah, I wonder why, like, look at this, you see this Epic Pen app, right, that's open, this little sliver thing that's expanding and whatnot. If I close this, right, close it. Actually, I got to close the whole app. But I wonder if this is an example of that because Command Q, there we go. So watch, when I open this up, it looks like it's doing, well, first of all, it looks like they fucked up the code on the initializer, now that we understand what that is. But it also looks like it's using lazy loading because it doesn't update itself until our cursor moves over it, and then it fixes itself because I assume it's doing some calculation of where the element should be, and it corrects itself. So look at this. This is actually, I think it's a perfect example. Okay, so if I open it up for the first time. Yeah, so you see that? I can't touch it because then it's going to fix itself, but you can see the right next to my cursor, to the left of it, it has a squished So it has two undo buttons. There should only be one. And it has two little trash can icons, which is the delete action. So neither one of those should have double. And you can see that both have skewed positioning. So it's squished. Looks like someone squished them with their finger. And also the copy button down here. You can even see it there. Or the settings button, whatever. But whenever I move my cursor over one of these, right? So I'm going to click it. Nothing happens. But as I move down over the element that's fucked up, they're using some kind of event listener, and then magically it fixes itself. See that there? Gotta have an eye for it, buddy. No, but really, I think that's something along those lines is happening. Pretty crazy, right? And this is the kind of shit they want you to pay for. No, I'm kidding. But I mean, I already, it's a great app. Don't get it twisted. They need to fix it. I already told them about it too. So, I mean, I don't like to bitch and moan unless you want to be part of the solution. So I did nicely just say, hey, this is fucked up. But it is a great app. I used it on Windows, still use it on Windows, have for years. It's perfect. Let me tell you, perfect on Windows. On Mac OS, we get this, but Mac OS has its own issues, so I'm not going to hold it against Epic Pen. But this is an awesome little app. It can do whiteboards and stuff. Look at that. You can do instant presentation. It's great. It's awesome. You can hide it. So yeah, no shade against Epic Pen, but it's just a good example. And it's interesting because now that we have learned this, it's interesting to see some of these things pop up, in software that you use on a daily basis. And now you're like, oh, that's probably what's going on there. All right, anyway, so back to this. Lazy degree. But yeah, I assume, my whole point in saying all that, I assume that's what they mean when they say if you use a lazy, see, this should not happen either. Come on, guys. I assume that's what they mean when they say, where did it go? I just read it. Yeah, lazy stacks trade some degree of layout correctness for performance. So the initial load is incorrect, but once it's up and running and fully expanded, I assume at that point it has all the information about your device, the resolution of your screen device, so it knows how big its device should be in relation to the 2560 by 1440p that I'm working on, and then it can auto adjust and correct itself. But yeah, all right, so now I'm just gonna have to quit you, buddy, because it doesn't want to behave at all today since I'm picking on it. Okay, where were we? When choosing the type of stack view to use, always start with a standard stack view and only switch to a lazy stack if profiling your code shows a worthwhile performance improvement. Okay. For more information on lazy stack views and how to measure your app's view loading performance, see Creating Performant Scrollable Stacks. I'm going to save that link because I do want to read that, but we will follow the instructor's instructions and not do that. We'll just read straight through and then come back to the course. So position views in a two-dimensional layout. To lay out views horizontally and vertically at the same time, use a lazy V-grid, use a lazy V-grid or lazy H-grid. Grids are a good container choice to lay out content that naturally displays in square containers, like an image gallery. Makes sense. Grids are, Grids are also a good choice to scale user interface layouts up for display on larger devices. For example, a directory of contact information might suit a list or vertical stack on an iPhone, but might fit more naturally in a grid layout when scaled up to a larger device like the iPad or Mac. Why do I have hiccups? All right. Yeah, I was thinking about this the other day. It's like I love my iPad Pro, but oftentimes I do. Well, how can I put this? I'll say it's hard to find, this mode, this scrollable vertical view, right? Obviously, there's some things this doesn't do well, but by and large, for me, it's hard to find a situation where I would not sacrifice. This is just personal preference. I'm just talking here, but it's hard for me to find situations where I would not happily sacrifice more real estate, like this view here on the right, to have the convenience of having everything right there, single-handed in that view, which I always found interesting. And I always thought about, even before I thought of writing an app in iOS, but now that I'm going to do it, it's really it's challenging my brain, I'll say. Because just as I'm thinking about the application, I'm like, man, so much of it really should be conveniently here. What do I really need this for? But we'll see. We'll see how it turns out. Like stack views, SwiftUI grid views don't inherently include a scrolling viewport. SwiftUI grid views don't. Oh, grid views. Only grid views don't inherently include a scrolling viewport. Place them inside a scroll view if the content might be larger than the available space. Oh, okay, sure. So just wrap this. Oops. No. Wrap this in a scroll view, and then we can scroll it. And we're all familiar with that view. I mean, that looks like your standard. If you ever use the iPad or a tablet, just scrolling on down in gallery view, looking at your photos. Okay, display and interact with collections of data. List views in SwiftUI are conceptually similar to the combination of a lazy VStack and a scroll view. Okay. But by default, we'll include platform-appropriate visual styling around and between their contained items. For example, when running on iOS, the default configuration of a list adds separator lines between rows and draws disclosure indicators for items which have navigation and where the list is contained in a navigation view. That's a lot of caveats. Wait, so the default config of a list, it gives you separators between rows. So that makes sense, and that's good. Draws disclosure indicators, which I think are those little carrots you can click, and it expands the list or collapses them for items which have nav, and where the list is contained in a navigation view. Okay, I guess that's not that many. List views also support platform-appropriate interactivity for common tasks such as inserting, reordering, and removing items. For example, adding the onDelete platform modifier to a for each inside of a list will enable the system standard swipe to delete interactivity. Yeah, which I think we all know what that is, or what they're referencing there. Like lazy HStack and lazy VStack, rows inside a SwiftUI list also load lazily, and there is no non-lazy equivalent. Okay, which lazy just means, I don't like the term, honestly. I think they should have called it, efficient VStack, efficient HStack instead of lazy, because lazy just means it doesn't load everything at once on startup. That way you don't have this super dog shit slow startup time for your app. Instead, it calculates, it knows what the user is looking at in the viewport, so whatever's available in the context window. And it knows, obviously it has the code of the application, so it knows when the user is scrolling down, just like I'm scrolling down on the web page, it knows what's coming next, so it can incrementally load the things that I need to see based off where I'm scrolling with my cursor and where I am in the current viewport. So it's what's the word? It is deferring to the user action instead of just assuming that it has to do all of the work up front. Instead, it lets the user dictate by virtue of just scrolling when it's going to load the rest of the content that's currently not shown by default. All right, group views and controls for data entry. Use form to build data entry interfaces, settings, or preference screens that use system standard controls. Okay. So I guess these are example of forms, what we can expect, which is nice. I mean, this isn't always quite so clear on the HTML side, so it's nice to have that continuity for sure. Like all SwiftUI views, forms display their content in a platform-appropriate way. Be aware that the layout of controls inside a form may differ significantly based on the platform. For example, a picker control in a form on iOS adds navigation, showing the picker's choice on a separate screen, while the same picker on macOS displays a pop-up button or a set of radio buttons. which these little blobs are radio buttons. They're the pick one buttons. You know, you can't pick multiple kind of a thing, but those are radio buttons. All right, so that makes sense. Yeah, it also explains why on some, like the Bear app, my favorite little note app. Always wondered why some of the options in here are just different in terms of how the interface is between the iPad and Mac OS, but I mean, that basically explains it. It's they didn't have a choice. But yeah. So I do wonder though if you can change that. You probably can, but we'll find out. All right, so now back to the compendium. Reveals that yeah. Toward the end of the article, you'll encounter the form type, which I've placed only in the preview code for now. The form type is tailored for data entry interfaces, settings, or preference screens that utilize system standard controls per the article. The distinct feature of this type is its out-of-the-box scrolling behavior and all-inclusive styling, adapting seamlessly to the operating system your app runs on. Yeah, that is pretty cool. Eliminating the need for platform-specific styling code. Oh my gosh. You get a new neck installed, brother. On iOS, a form visually resembles a grouped list. Featuring the standard gray background, rounded sections, and adaptable row dividers. Removing the form from the preview code will remove all formatting. Okay, so down here, is this, yeah, this is the, oh, there it is, form right here, line 33. Well, I mean, if I do that, nothing's gonna be there anyway. Yeah, I'll take his word for it. Okay, so laying out images, text, and other content without using stacks. Okay. In the text input and output section, the label view is detailed. Apple provides this view for combining images and text rather than consistently resorting to a stack with an image and a text view. Let's go read this then, because I'm not sure if this was already in that article. Yeah, no, this is different. Okay. So this is text input and output. I want to make sure he's not asking me to read something else. Okay, we'll start here. All right, text input and output. Display formatted text and get text input from the user. To display read-only text or read read-only text paired with an image, use the built-in text or label views, respectively. I'm going to cheat just a little because I want to understand the difference. I assume label can't hold as many characters minimally. Text, a view that displays one or more lines of read-only text. Okay, one or more. Okay, well, I mean, that's pretty straightforward. I think we understand what text is, but that is the Apple definition, so one or more lines. Fair enough. Label, a standard label for user interface items consisting of an icon with the title. Okay, so I suppose that's main difference there. There's a asset associated with label, the icon, and a title. That makes sense. So they really do work together, but you might, I suppose there'd be some cases where you would just have one or the other, but yeah, okay. So we won't stick here too long. Let's go back. I just wanted to see what the difference was by Apple's definition. So when you need to collect text input from the user, use an appropriate text input like text field or text editor. Oh, yeah. I want to see this. I wonder if they give you a WYSIWYG A text editor view allows you to display and edit multi-line scrollable text in your app's user interface. By default, the text editor view styles the text editor view styles the text using characteristics inherited from the environment, like font, foreground color, and multi-line text alignment. Okay, I thought they meant like presenting a text editor to the user, but that's okay, so it doesn't matter. Okay, so these are for text input, text field, or text editor. Okay. You add view modifiers to control the text font, selectability, alignment, layout direction, and so on. These modifiers also affect the other views that display text, like the labels on controls, even if you don't define an explicit text view. Oh, excuse me. I don't know why I'm yawning. These modifiers also affect other views, like the labels on controls. Other views that display text. I guess within the... Yeah, I'm not sure what they mean by that. What would be inside of a text view itself? For design guidance, see typography in the human interface guidelines. Yeah. We'll refrain for now, but yeah, I think the main takeaway, these are the two views if we want to take user input, at least for now. The label view is detailed. Wait. In the text and output section, the label view is detailed. Apple provides this view for combining images and text rather than consistently resorting to a stack with an image and a text view. Okay, that does make more sense now. Similar to the image type, the label type also accepts an SF symbol name available in the FS Symbols app. Okay, what is that? San Francisco? San Francisco Symbols provides thousands of consistent, highly configurable symbols that integrate seamlessly with the San Francisco system font. Hold on, what's it? Oh, thank you, baby. That's very sweet. She's the best. Okay. SF Symbols provides thousands of consistent, highly configurable symbols that integrate seamlessly with the San Francisco... Oh, it really... I was just kidding. San Francisco system font, automatically aligning with text in all weights and sizes. Skirt! Okay, what? SF Symbols provide thousands of consistent, highly configurable symbols. Really? For free, brother? If it's free, I'm gonna be pissed. I paid $180 last year for it. Actually, I mean, it was $180 for what was it? Icon Scout. Yeah. But honestly, I mean, it is expensive, I guess, but it was a great... I mean, they have great icons, literally anything I could think of. So I mean, it's not like it wasn't worth the money. It was just more than I was used to paying for that. But yeah, I mean, it would be nice if there's a massive library of that on iOS for free. So visit SF Symbols to download the app and browse. Be sure to understand the terms and conditions for using SF Symbols, including the prohibition against using symbols or images that are confusingly similar in app icons, logos, or any other trademark use. What? So you can't... What is the point of... with over 5,000 symbols, that's a library of iconography. Designed to integrate seamlessly with San Francisco, the system font for Apple platforms. Comes in 9 weights, 3 scales, and automatically aligned with text. They can be exported and edited using vector graphics. Vector graphics, if you don't know, versus raster. Like if you've ever edited a photo and you blow it up or you try to resize it and it gets all pixelated and whatnot, those are raster graphics. Vector graphics are... They can scale infinitely, and you'll always have smooth lines. So it kind of depends on what you're making, but generally speaking, I think a lot of technology is moving towards the vector graphics, as evidenced by many of the popular illustration and like artwork, video editing, painting type apps that are on the iPad and other platforms. But neither here nor there. So symbol animations, a collection of configurable animations, provide a new dimension. Oh, cool. Yeah, but is it what was all this about? What's this about licensing and all that? Download? Okay. Oh, there we go. Yeah, this is one of the funkiest things. When I first got a Mac, I was actually shocked at the way you install apps. It's just so I mean, it's not bad necessarily. It's just so different. It almost feels like a toy. I'll show you though. It's just really weird. Come on, governor. Oh, good. Here's a different. Actually, don't know what is. Oh, okay. Never mind. So there's three different kinds. There's the DMG, which this one's more akin to what we're used to on Windows. So, yeah, shut me up, brother. Never mind. Install for all users. It doesn't matter. I just want to see what's in here. Close. All right, now let's look at how to use. Yeah, I guess this is what we want. And this is where I was. Okay. I'm going to come back and read this. I'm just looking for. Maybe I misunderstood, but I'm looking for the bullshit. Where's the gotcha? Animations. No. Animation work. Animations work on all SF symbols in the library, in all rendering modes, weights, and scales, and on custom symbols. For considerations when animating custom symbols, see custom symbols. Okay, maybe there isn't one. Replace now. Apply symbol animations judiciously. Clear purpose. Create a symbol first. Export the template for a symbol that's similar. Use a vector editing tool. Oh, good. Okay. That should be cool. We will try that out. Assign. I don't see anything about no additional considerations. Don't design. Apple products are copyrighted and you can't reproduce them in your own custom symbols. Also, you can't customize a symbol that SF Symbols identifies as representing an Apple feature or product. Oh, okay. So that must have been what that was about. So just with Apple stuff. Well, that's nice. It's really nice. This, you know what this reminds me of? So it makes sense that Apple would have an equivalent, but Lottie, I think it's called Lottie, for the web is, yeah, this SVG animation. It's pretty cool, but it's kind of the same thing. You can take your SVG icons and, run JavaScript or whatever it is. I'm not sure that it's even directly JavaScript. It might just be a direct browser implementation, but it can animate those. So it seems like that's the Apple equivalent. All right, well, that's cool. Okay, so SF symbols then. And I might as well, I'm going to go ahead and save that. keep it in the dock rather. Yeah, look at all this. Hold on a minute. Hold on. I'm going to look at these. That's pretty sick. I mean, damn. Yeah, okay. Well, that is a big plus. Save me 180 bucks. I won't be renewing my Icon Scout. Thanks, Apple. Thanks, Tim. All right, so now let's go back. Instead, I'll just never mind. I'm not gonna say that. SF symbols app. Okay. Additionally, within a form, a label inherits other styling attributes such as icon color and image text spacing. Additionally, within a form, a label. Oh yeah, sure. Placing information on the trailing side of a settings row is a standard interface practice. SwiftUI offers the badge modifier for this purpose. The badge modifier. What is the badge? Generates a badge for the view from it. Oh, the badge is a little like red number that pops up when you have like a notification on each little app icon. Or it's a form of a badge. Func badge. An optional text view to display as a badge. Set the value to nil to hide the badge. Okay, that's pretty straightforward. Use a badge to convey optional supplementary information about a view. Keep the contents of the badge as short as possible. Badges appear only in list rows, tab bars, and menus. Badges appear only in list rows, tab bars, and menus. I guess the home screen on the iPhone qualifies as a menu. So use this initializer when you want to style a text view for use as a badge. The following example customizes the badge with the monospace digit, foreground color, and bold modifiers. Okay, cool. So let badge view, so that's a constant, a text view, and then inside it, we escape and pull in a count of recent items. So that would just be an integer that we're pulling in. Then we apply these modifiers, monospace, foreground should be red, and then we want to bold all of the text. And the list builder, or the view builder, in this case being list. So we have two text records, recents and favorites, where recents should have whatever badge view is, which is this, what we just defined. Okay. And yeah, all right, there you go. 21 recents. I like it. Yeah, it's pretty straightforward. I didn't know it could do this though. I thought it had to be the little thing, so that's cool. All right, that makes sense. Now let's go back. Badge modifier for this purpose, which you can find within the list documentation. To highlight an important badge, use the badge prominence view. All right. I think I'll swap these because the right click menu is not... it's not menuing. The page you're looking for cannot be found. Boo. Wait, this badge prominence? Lincoln. Yeah, I guess not. Okay. We will just search for it. Prominence burn. Only the real ones will know. It's My Hero Academia. Poor endeavor. Bro can't catch a break. Actually, that's not true. I guess he was kind of an asshole, but whatever. A type indicating the prominence of a view hierarchy. There we go. Badge prominence. Why are there two? Badge prominence. The same thing? Oh, that's in journaling. Okay. Specifies the prominence of badges created by this view. It's a function, badge prominence, takes an anonymous parameter for the first argument of type badge. Oh, it's the only one, so we don't have to name a parameter. And it has to conform to view. Discussion. Badges can be used for different kinds of information, from the passive number of items in a container to the number of required actions. The prominence of badges and lists can be adjusted to reflect this and be made to draw more or less attention to themselves. Badges will default to standard prominence unless specified. The following example shows a list displaying a list of folders with an informational badge with lower prominence, showing the number of items in the folder. Okay, so here's the list. We want to apply it against folders. And then here's what is this? A trailing closure folder in. So here's the argument, and then we want to list the name of each folder and then apply this badge to each of those records. So we should have a record for each folder and also a number to show how many files are in the folder with a prominence setting of decreased, whatever that looks like. Oh, they don't show you. Boo. Well, we can infer what that might look like. But at least we can read the code, so that's nice. So we understand what it's doing at least. All right, so in iOS, this will highlight the badge with a bright red circle. Oh, if it's important, not decreased. So I'm sure it's easy enough to find examples and we'll come across it soon enough. However, note that the badge modifier is restricted to list and does not function similarly within forms on other platforms. A more versatile and commonly used alternative is the labeled content type, listed in the view grouping section along with the form type. All right, well, let's go look at that. Hot-blooded. All right, a container for attaching a label to a value-bearing view. Oh, finally they responded. We're going to look at a few homes next week and trying to herd these brokers like cats, man. Bam, certified. Okay, cool. Thank you, brother. Great. If this fucking net didn't get out of my face. Okay. Where are we at? Oh, labeled content, yeah. A container for attaching a label to a value-bearing view. A container for attaching a label, which we know is an icon and a string, effectively, to a value-bearing view. Okay. I just want to like take my neck off and that's what it feels like it needs to do. Too many shrugs. The instance's content represents a read-only or read-write value. The instance's content represents a read-only or read-write value, and its label identifies or describes the purpose of that value. And its label identifies or describes the purpose of that value. Oh, okay, yeah, that makes sense. Okay. Which is why, yeah, okay, item count. Okay. The resulting element has a layout that is consistent with other framework controls and automatically adapts to its container, like a form or toolbar. Some styles of labeled content also apply styling or behaviors to the value content, like making text views selectable. Okay, show me. The following example associates a label with a custom view and has a layout that matches the label of the picker. The following example associates a label with a custom view and has a layout that matches the label of the picker. So this whole thing wrapped in a form. Here's the labeled content, custom value. So they're saying this, whatever your first or the argument is, should describe the whatever the value is that you're pulling in. My custom view value. Okay, I mean, yeah, I really wish they would have shown. I wonder if, can I throw this in preview? Yeah, I think that should work, maybe. Yeah, I just want to see what it is. My custom view. My custom view. God damn it. All right, you know what? Forget it. We'll get there eventually. I'm surprised though. Some of the other, maybe these are getting updated. I don't know. Some of the other ones we saw yesterday, they all had visuals, visual examples, at least the output of what that would be. I wonder if there's a, we can wait. If they don't get to visuals soon though, I'll find a playground or something, just somewhere I can throw these and see the output. That would be nice. Okay, custom view labels. You can assemble labeled content with an explicit view for its label using the initializer. So initializer, then we pass it the content and label. For example, you can rewrite the previous labeled content example using a text view. Yeah, I mean, I'm going to go back for now because we've entered what the fuck realm. I don't know where they're at all. However, note that the badge modifier is restricted to list and does not function similarly with forms on other platforms. At least I know what the badge is and what it does because we saw what it is. View groupings. Oh yeah, that's where we got off. View groupings, yeah. Like the label type, labeled content derives its styling from the surrounding container. In our case, a form. This includes a lighter color for its content. The content of the labeled content view can also be styled using the labeled content style view modifier. However, the labeled content style protocol does not provide any styles other than the automatic one. This means this style is only useful for creating custom styles to change the layout of the labeled content views in your app. This means this style is only useful for creating custom styles. However, the label does not provide any styles other than the automatic one. Useful creating custom styles to change the layout of the labeled content. Yeah, we got to get into the example project soon, hopefully. Come on, man. How much more of this is? Formatting and composing text with specialized initializers and operators. Another aspect to notice is a couple of features of the text view. Primarily, I utilize a different initializer in the birthday row to format the date type derived from our data. Okay, I'm a dumb. I think in my willingness to placate the grammars, I was missing out on all these examples. I didn't realize he was. Oh my god. Okay, maybe this is. All right. So now let's go back. Let me go back to. Is this all inside? So it should all be in this personal information. So in this file, okay. Now let's look at this. Toward the end of the article, you can kind of form type. So where are we actually using that in the body? Only in the preview. Okay. Personal information, person, we pass in the preview data. The form type is tailored for data entry interfaces settings. Oh yeah, we saw that. This type is out of the box. A form visually resembles a grouped list, which that holds. That's what our preview shows. Won't. Okay, there we go. In the text and text input and output section. So where is that at? I wanted to see where he put that. Well, it can't be here because there's no text box, but maybe. Okay, we're just not there yet. All right, let's keep going. Wait, what does this say? This is the author of the course. I made a mistake and published an older version of the code that used text instead of label. It's fixed now. I added the Xcode project to the course page. Whenever you find a problem in a lesson, refer to it. That should usually be correct. Okay. Here we go. Storing mutable state in views and updating it through bindings. SwiftUI offers several interactive controls for inputting and altering data. These controls must be connected to a mutable state for interaction to occur. Storing and updating state in SwiftUI views. The Managing User Interface State article explains how to utilize the state and binding property wrappers. These wrappers store mutable state within a view and establish connections between interactive controls and this state. Okay, here we go. This is what show me this, because it's all a bit too esoteric to this point. This enables us to begin using the views listed in the controls and indicators section of the documentation. Yeah, so I'm just going to go through the course. I'm not going to read the Apple Docs unless something really just doesn't make sense, because yeah, I'm not liking it so far. I thought we'd already be in the project code, but it's kind of disjointed, honestly. All right, so delivery.swift. Let me open that. Delivery. Okay. So this is. Oops. Just a hair bigger, man. Just right. There we go. Now I can hang around. Give me this. Go over here. Okay, so this is what we're looking at least to have one example up. Hopefully we can refer back to it. So delivery Swift, preview data, we don't have open. Let me open that. Preview data. Preview data. I take it I can't move these after the fact. That sucks. I wish you could. Yeah, I can't. Okay, that was a bad idea. Never mind. Fuck it. Okay, delivery.swift, preview data, delivery preferences. There we go. And that's it. Okay. All right, this enables us to, okay, yeah, so we're good to go here. So that's what that builds. All right, there's a nice little visual. Thank goodness. All right, so this, let me look at this. That's crazy. It's a lot of code for just that little view, huh? Struct delivery. So type delivery, 3 mutable variables, true, false, locale, weekday. I assume that's built into the framework, so you can get the right language and whatnot. And the date too, probably pulled from the system or from the operating system. Preview data, we know what this is, so that was just for developer work. Makes it easy to constantly have data to work with. So we looked at that. Delivery preference.swift. So here we have another custom view with the state attribute, which I forget what this does. So maybe we should go read that article then, because oh, whoops, I need that link. Yeah, this guy. In the bottom. All right, managing user interface state. Encapsulate view-specific data within your app's view hierarchy to make your views reusable. Store data as state in the least common... let me move it. Center it up. Store data as state in the least common ancestor of the views that need the data to establish a single source of truth that is shared across views. Store data as state in the least common ancestor. Least common ancestor. Provide the data as read-only through a Swift property or create a two-way connection to the state with a binding. SwiftUI watches for changes in the data and updates any affected views as needed. Yeah, you know, I was kind of shitting on the big nerd SwiftUI chapter, but I think it was actually a lot more helpful because it was just straight examples, and we did see the binding in action. It was pretty straightforward, but it's just hard to follow it without examples. So I may have to bail on this course and just hop to the book because yeah, I don't know, but I do want to know. I would like an explanation on what, or more examples rather, on least common ancestor. Below is an excerpt, a SwiftLang course. Please expound on least common ancestor in relation to state management. Think of your SwiftUI views as forming a tree-like structure, like the DOM. The topmost view is the root, and each view can have child views. The least common ancestor of 2 or more views is the highest view in this tree. Okay, say less, brother. All right, no, that's good. Okay, that makes sense. All right, don't use state properties for persistent storage because the life cycle of state variables mirrors the view life cycle. Right, yeah, it's only in memory until you scroll away from it or change views and then it's gone. Yeah, so you should save it to disk or somewhere. Instead, use them to manage transient state that only affects the user interface, like the highlight state of a button, filter settings, or the currently selected list item. Yeah, you might also find that this kind of storage Wait, you might also find this kind of storage convenient while you prototype, before you are ready to make changes to your app's data model. Okay. Manage mutable values as state. If a view needs to store data that it can modify, declare a variable with the state property wrapper. Okay. If a view needs to store data that it can modify. Okay, yeah. So, yeah, like in my case, my application will let people pull in. It's going to make a call to their SQL backend, ingest some filtered data set, which will go into the SQLite local storage and effectively give them a sandbox on the local device to play around with that data using the tools that the app will provide. So we will definitely be using this quite a bit. For example, you can create an is playing Boolean inside a podcast player view to keep track of when a podcast is running. You can create an is playing Boolean inside a podcast. Okay, yeah. Struct player view, state attribute, private, so it can't be modified outside this view. Okay. Marking the property as state here. So there's two markings, really, the state and the private, ahead of the keyword variable. Marking the property as state tells the framework to manage the underlying storage. Your view reads and writes the data found in the state's wrapped value property. Your view reads and writes the data found in the state's wrapped value property. I'm going to come back to that. I want to read that, but I think I remember what it's describing. By using the property name, when you change the value, SwiftUI updates the affected parts of the view. Oh, that's right. It said that. It has the observers, and so it invalidates the view, re-renders, and it pulls in the new binding. Okay. For example, you can add a button to the player view that toggles the stored value when tapped, and that displays a different image depending on the stored value. You can add a button to the player view that toggles the stored value when tapped, and that displays a different image depending on the stored value. So, okay, so true or false, and true and false can both have a different visual representation to the user. So button, then we explicitly say action for the parameter here, and then we give it a closure, a trailing closure. Oh, just for the argument though. Okay, so yeah, so self-referencing, meaning the instance, whichever instance it may be, that's how we refer to it. The self, little self, dot is playing, dot toggle. So that's just a method on that struct. Or sorry, on that property. Okay, so that's the arguments, and then image, system name, so that's our parameter. Is playing. Image system name. Why is system name? So is playing is the variable. This is the ternary operator. So if it's true, if it is playing, or if it's equal to true, then it'll display the pause button, which makes sense because when we're actively playing a video, we see the pause icon. When we pause it, it toggles over to a play button. Okay, I'll follow you. Limit the scope of state variables by declaring them as private. This ensures that the variables remain encapsulated in the view hierarchy that declares them. Yeah, because you wouldn't want something else really jacking with that status because it could get out of sync, which does happen. So that's why sometimes it's like a lot of times that happens on when you use web or when you use websites on your phone, where normally there's an app, you know, it's kind of janky functionality. Like if you go to YouTube on your iPhone through the browser, not through the app, some of that can be a little jank sometimes. All right, declare Swift properties to store immutable values. To provide a view with data that the view doesn't modify, declare a standard Swift property. For example, you can extend the podcast player to have an input structure that contains strings for the episode title and the show name. To provide a view with data that the view doesn't modify. Okay. Extend the podcast player to have an input structure. Okay, player view. There's the conformance episode. Here's our wrapped state variable. Where is the declare a standard Swift property? Oh, I guess that's what, just with the let, just a constant. Okay. While the value of the episode property is a constant for player view, it doesn't need to be constant in this view's parent view. When the user selects a different episode in the parent, SwiftUI detects the state change and recreates the player view with a new input. What? While the value of the episode property is a constant for player view, meaning it cannot be changed, it doesn't need to be constant in this view's parent view. In the player view's parent view, what do you mean? What are they talking about? Well, the value of the episode property is constant for player view, which is what this is here. It doesn't need to be constant in this view's parent view. Okay, yeah. Okay, so they are saying it. When the user selects a different episode in the parent, SwiftUI detects the state change and recreates the player view with a new input. So I would think what they're saying is you would wrap this, and you could also have a episode property in the surrounding view, and that could be a var instead of a let, which can change. And when you do that, since the player view, let's try out some squares, brother. So this would be the parent view, and then this. Whoops. So the inner view is inner player. So this is the smaller box inside is the child, and that's what we're looking at in terms of the code in the background. But they're saying there would be a parent view, and both of these would have, well, the parent scope here would be var episode, so that it can change. And then inside player view, it's a let, which cannot change. But anytime that we, just based off how SwiftUI works, we learned this. So anytime we change the var, the episode property, in the parent view, then it's going to invalidate everything beneath it automatically, and then re-render it. So the constant never gets changed, but the view gets recreated with whatever the new value is from the parent view. And then that just gets recreated with the updated value. And so it's not the same as directly changing it. You're really just recreating it. But I believe that's what they're saying. All right, so then that makes sense. We did see that in the big nerd example to an extent. Okay, so tracking, brother. What's next? Well, the value of the episode. Oh, we read that. Share access to state with bindings. If a view needs to share control of state with a child view, yeah, kind of like, because I mean, my application will have this where if you change anything, like all of the child views would effectively be, you can think of it as like, for example, AR invoices, right? There's always going to be many, many, many child invoices coming into a view. Like each of those would represent a view, a data record, and the parent view would be some kind of aggregate representation of all of the underlying invoices. So that would need to have some kind of, well, maybe I guess it could just recalculate. Maybe not two-way binding. Yeah, never mind. That would be the opposite. But either way, what would be a two-way? I guess if you had in your interface two different areas where you could amend the same value. Like I know in a past life in old systems, we would build a lot of web views that would only show some subset of the program's values, because you don't want your warehouseman to be able to see your GL, like your ledger. Wouldn't be any reason for that. They need a very small subset of the functionality and subset of the data that's available to the company's system in order to do their job. So we just build them some consolidated view. But in some cases, there are things that they manage. And so like say a warehouseman needs to amend inventory levels. He needs to do a inventory adjustment for certain items. But so too, the people in the front office in AR or in purchasing, something like that, they might also have some kind of side channel receipt where they need to amend inventory stock levels. So that could be a good example of a two-way binding, because more than two interface points at any given time need to be able to edit the same value that would represent the on-hand stock for a given item, like the quantity, however much you have on hand. All right, but if a view needs to share control of state with a child view, declare a property in the child with the binding property wrapper. Oh, that's nice and easy. A binding represents a reference to existing storage. Yeah. Preserving a single source of truth for the underlying data. For example, if you refactor the podcast player views button into a child view called play button, you can give it a binding to the is playing property. Okay, wait, so for example, if you refactor the podcast player views button into a child view, you can give it a binding. Okay, let's see. Some view. Versus, what's the difference? Oh, this is all one VStack. And this is, so here's a button. Wait, why is that a child button action? Okay. Yeah, let's go back to the course, because they had me for a second there, but oh wait, here it is. Oh, okay, that makes more sense. I guess that's the first example. As shown above, you read and write the bindings wrapped value by referring directly to the property. As shown above, you read and write the bindings wrapped value by referring directly to the property. Is playing. Oh, okay. Directly to the property, gotcha. Self, hence the self is playing, which is up here, and then toggle it. And that applies because it's a bool. Okay, I gotcha. All right. Just like state. But unlike a state property, the binding doesn't have its own storage. Instead, it references a state property stored somewhere else and provides a two-way connection to that storage. Oh. but okay, but where is that? When you instantiate play button, provide a binding to the corresponding state variable declared in the parent view by prefixing it with the $sign. Okay, yeah, this is that's what we saw in the book, and this is what made sense a lot to me, because this is I mean, this works a lot like Svelte or jQuery, or a lot of JavaScript frameworks, even some PHP action. But yeah, the $sign for the binding is recognizable for sure. Okay, so player view episode is now a var. State wrapper around is playing. It's a bool and its default value is false. I think I like this better. And then you can put this all in a vertical stack. We wrap the two text views, and in the play button instance for is playing, we pass in the binding to this guy up here because of this. Okay. Where do you modify it then? Maybe I guess maybe they'll tell us. I don't know. I would expect to see the toggle still though, but okay, as shown above, you read and write the binding's wrapped value by referring directly to the property, just like state. But it doesn't have its own storage, references two-way, yada yada. When you instantiate play button, providing a binding. Yeah. Oh, I'm a dummy. Okay, they're supposed to work together. Okay, so player, this is the play button view. I see. Okay. So in the play button, dang, my bad. All right. So we want to bind to is playing in the play button itself. And that's why we only have the toggle here, because this is the button. And then the overall view itself uses the play button down here. Okay. I gotcha. So, okay, I do like this better, because this is, I got it. Okay. It's just binding to this up here. Pow. Okay, my fault. Yeah. That was it was not hitting there for a while, brother. All right, so now let's move on. The $sign prefix asks a wrap property for its projected value. Yeah. This, I need to save this just because I'm going to cheat and read through this real quick, because this is projected value is one of my favorite features that we came across. So this will be good to review. All right, a binding to the state value. Or if I'm remembering this right. Use the projected value to get a binding to the stored value. The binding provides a two-way connection to the stored value. To access the projected value, prefix the property variable with a $sign. Okay, I mean that's not wrong, but that's not what I wanted to. I'll just tell Gemini to do it. But I mean, that's relative to SwiftUI, but projected values do a lot more than that. So I want to get a refresher on that. Please provide. You got to be nice to it. Please provide a summary of projected values and their use cases in Swift. All right, what are they? In essence, a projected value is an additional value that a property wrapper can expose alongside the primary wrapped value. This is often used to provide extra functionality or information related to the wrapped property. Yeah, so the way that when we first came across this, the way I thought about it was because in my world, where I come from, see, um, because I'm constantly relating this to what I'm planning on building and a lot of the heartache that I collected over the decade, from customers, working with customers around these different kinds of applications that manage inventory. So a lot of times people would always ask for these kinds of shadow values where while they're interacting with numbers in the system, if at the same time, like let's say you're a warehouseman and you're out there doing a physical count, you're counting inventory, and you want to hedge against big mistakes in counting, because if things are, I don't know if you guys have ever been involved in a physical count, but normally, I mean, you're literally counting everything. That's why they only generally do it once a year. Some not even that, but normally you will break out your entire, or break down your entire physical warehouse, wherever you keep inventory. You'll break them out into sections. Normally there's some kind of tag system that will get implemented so people can, like let's say you have 10 people and you have 10 racks of inventory. So you want a tag to represent each rack. Everyone gets that singular tag. They come back, they return the tag to you with the counts on them. And then you compare what was counted versus what the system said that you had. And you analyze those discrepancies. If it's way too far off, so if you're based off your counts, if you're missing $1 million in inventory, more than likely you're gonna want to recount that before you just take a fucking hit like that, right, on the books. So a lot of times what they would want is some kind of quote unquote, they always called it smart. That seems to be the go-to customer terminology, but they're like, can it provide some kind of smart calculation where the number that they say they counted gets compared to some kind of computed background value as they enter it. That way it's more or less a way for the counter themselves to immediately see discrepancy so they can recount on the spot if they're too far off. Now it might be that they're accurate and it just is what it is. Like, yeah, someone walked out with 80 cases of finished goods or whatever. But it's just a way to associate. The way I look at it, just well, like I said, I call it a shadow value, but some kind of computed value based off of logic or whatever algorithm alongside an actual value for a quick reference point in real time. So that's what I think of when I think of this, because you can add a value alongside some kind of computed value. So one can actually go grab data from the database and it just is whatever it is, whatever the system says. But then you could have this projected value where it's accounting for some kind of business logic that the organization arrived at that they want to base decisions off of as some kind of threshold. Does that make sense? Probably does. Probably makes perfect sense. All right, so let's go back and get to it. All right, so but yeah, they're talking about it in a different way because this is in the SwiftUI context, not just straight up Swift. But yeah, it has more application than just here. For its projected value, which for state is a binding to the underlying storage. Similarly, you can get a binding from a binding. You can get a binding from a binding using the $sign prefix, allowing you to pass a binding through an arbitrary number of levels of view hierarchy. Oh. You can also get a binding to a scoped value within a state variable. Okay, for example, if you declare episode as a state variable in the player's parent view, and the episode structure also contains an isFavorite Boolean that you want to control with a toggle, then you can refer to episode.isFavorite to get a binding to the episode's favorite status. Where is that at? Okay, so this is podcaster view. We mark episode as state. Oh, I see. So if we mark episode as state, when we initialize it, we get this property, and they're saying that we can access that property from the toggle with this $episode dot is favorite. So we already knew we could get here, but they're also saying you can get to the properties as well with the binding. Okay. Toggle favorite is on. Okay. Yeah, that's cool. All right, animate state transitions. When the view state changes, SwiftUI updates affected views right away. If you want to smooth visual transitions, you can tell SwiftUI to animate them by wrapping the state change that triggers them in a call to the with animation function. You can tell SwiftUI to animate them by wrapping them. Okay. For example, you can animate changes controlled by the is playing Boolean. That's cool. It's pretty straightforward. Just 3 lines with animation, and then the modifier. The modifier takes apparently at least 1 argument, which is duration, so 1. And then trailing closure, so self for the current instance is playing gets us to the property, and then we call the toggle method on that property. Okay. By changing is playing inside the animation function's trailing closure, which would be this thing, or this thing, you tell SwiftUI to animate anything that depends on the wrapped value. Okay. Like a scale effect on the button's image. Wait, by changing is playing inside the animation to animate anything that depends on the wrapped value. So anything that depends or has is playing as a property. So image is playing, ternary, pause or play, and then we want to scale the is playing property with another ternary, either 1 if it's true or 1.5 if it's false. So I guess slightly upscaling the play button. Okay. SwiftUI transitions the scale effect input over time between the given values of 1 and 1.5 using the curve and duration that you specify. Okay. What does that mean? Over time between the given values. Oh, so move from 1 to 1.5 in scale, but where's the duration though? Transitions the scale effect input over time between the given values of 1 and 1.5 using the curve and duration that you specify, or reasonable default values if you provide none. Okay, so I guess we just chose none in that case. On the other hand, the image content isn't affected by the animation, even though the same Boolean dictates which system image to display. I guess that's the only part that's thrown. I don't know why that's the parameter system name. Seems off. I would have thought image name or something, but whatever. On the other hand, the image content isn't affected by the animation, even though the same Boolean dictates which system image to display. That is because SwiftUI can't incrementally transition in a meaningful way between the 2 strings pause.circle and play circle. Okay. You can add animation to a state property, or as in the above example, to a binding. Either way, SwiftUI animates any changes that happen when the underlying stored value changes. For example, if you add a background color to the player view at a level of view hierarchy above the location of the animation block, SwiftUI animates that as well. If you add a background color to the player view at a level of view hierarchy above the location of the animation block. Above it, and it still animates it? Oh yeah, they're just yeah, they're using whole different vernacular. But yeah, this is nothing different than what we've already seen. So I mean, we would expect this because we know that each view from a top-down perspective, like text runs, it returns a view. This runs again, it returns a view, and then play button, since it's last in sequence, this would, and this has the binding to the animation, then it would animate the whole thing. Yeah. When you want to apply animations to specific views rather than across all views triggered by a change in state, use the animation value view modifier instead. Yeah. Okay. Yeesh. When are we going to get into the Xcode, brother? Come on now. We'll give it 2 more chapters. If not, well, I might just go straight to the big nerd, because I'm waning. That's all I'll say on this course here. This enables us to begin using views, listed in controls. Okay, we read that. Looked at all this. Yep. Controls such as toggle picker or date picker might initially appear confusing due to their requirement for a view builder. However, after encountering the labeled content view in the previous lesson, how these arrange the view label and its content becomes more evident. Let me see. Let me check if Kindle. I think if this was the first book we covered, but the iOS one, if this covers SwiftUI, I think I'll just go ahead and start that, because I mean, it's hard to go from this style, which is really good, and I really enjoyed it, to what we're looking at now. No shade, just saying. Not really resonating with me, but let's see. So is SwiftUI here? Swift language, views and view hierarchy, view controllers. I mean, actually, it's probably in the, yeah, let's just read the, usually there's like a who is this book for, and then it tells you what it covers. You must learn the Swift language, and you must master the big ideas. You must master the frameworks. Actually, yeah, I'm just going to start here instead of sifting, because I'm almost positive we'll cover this. If we're covering the frameworks, we're going to cover SwiftUI. So, you know, not saying this is a bad course at all. It doesn't, you know, it's not jiving with me, brother. And plus, I already know what I'm getting with Big Nerd, so I'm just going to go ahead and make an executive decision and divert, leaving you in the dust. All right, so let's go. All right. Am I at the beginning? I am. Actually, I want to just look real quick and see. Well, there's a better view. I just want to see what all it covers, and then we'll get cracking. All right, so First section, a simple iOS app. So actually straight away, first chapter, get to building something, which is perfect. That's much better. So we'll create an Xcode project. We'll cover MVC, model view controller, interface builder, building an actual interface, creating a model layer, and we'll finish the app, build and finish the app. Then app icons, launch screen. For the more curious, running an app on a device. Okay, that'll be cool. Then there's a chapter on the Swift language itself. Then views and the view hierarchy, which is probably where we will cover SwiftUI, chapter 3. Yeah, so that should be just fine. And then view controllers, chapter 4. The view of a view controller, initializing tab bar, interacting with view controllers. Yeah, programmatic views. Text input and delegation, internationalization and localization. All right, and debugging. 9 is UI table view and UI table view controller. Okay, sounds good. Chapter 10, subclassing UI table view cell. 11 is stack views. 12, navigation controllers. God damn. 13, saving, loading, and scene states. Okay, yeah, we're going to be, because I already see the protocols from SwiftUI, which was Codable was one of them. Chapter 14, presenting view controllers. Chapter 15, interacting with the camera. Oh, that'll be cool. On the device. 16, adaptive interfaces. Chapter 17, extensions and container view controllers. 18, custom controls. 19, controlling animations. 20, web services. Oh, sick. Yeah, web services. That'll be good. 21, collection views. 22, core data. 23, core data relationships. And 24, accessibility. All right. Yeah, we're going to start here. It's just, it's better. All right, as an aspiring iOS developer, you face 3 major tasks. You must learn the Swift language. Swift is the recommended development language for iOS. The first 2 chapters of this book are designed to give you a working knowledge of Swift. So that should be easy money for us. You must master the big ideas. These include things like delegation, archiving, and the proper use of view controllers. The big ideas take a few days to understand. When you reach the halfway point of this book, you will understand these big ideas. Okay? You must master the frameworks. The eventual goal is to know how to use every method of every class and every framework in iOS. That's a joke, probably. This is a project for a lifetime. There are hundreds of classes and thousands of methods available in iOS, and Apple adds more classes and methods with every release of iOS. In this book, you will be introduced to teach. In this book, you'll be introduced to each of the subsystems that make up the iOS SDK, software development kit. But you will not study each one deeply. Hiccups. Instead, our goal is to get you to the point where you can search and understand Apple's reference documentation. Not unlike what the last guy was trying, but yeah, we just prefer this teaching style over here. Okay, we have used this material many times at our iOS boot camps at Big Nerd Ranch. Okay, it is well tested and has helped thousands of people become iOS developers. We sincerely hope that it proves useful to you. Prereqs. This book assumes that you're already motivated to learn and write iOS apps. We will assume. If this is not true, you should probably start with Swift Programming, the Big Nerd Ranch Guide. Oh, and we did that. What has changed in the 7th edition? Yeah, that's fine. We don't need to read that. We already are sold on their teaching philosophy. Using an ebook. Well, if you're reading this ebook, or if you're reading this book on a Kindle or iPad, we want to point out that reading the code may be tricky at times. Longer lines of code will wrap to a second line, depending on your selected font size. This bothers us because we are really conscientious at Big Nerd Ranch about the way our code appears on the page. Clear visual patterns in code make that code easier to understand. The longest lines of code in this book are 86 monospaced characters like this one. Okay. You can play with your Kindle settings to find the best for viewing long code lines. Oh, I see. So they're saying, all right, so this should fit on one line, and so long as it does, then we're good. So maybe I can afford a little. What is that? Open dyslexic. That does not help, brother. Let me tell you. I kind of like that one. Okay, there it is. It's a little too big, kind of, but yeah, that's fine. All right, so that should work. Actually, I'm gonna go down just one notch. I feel like it's gonna slap me in the face. Ah, good old Kindle interface. Okay, there we go. When you get to the point where you're actually typing in code, we suggest opening the book on your Mac and Kindle. Oh yeah, sure. Oh, good. They have detailed breakdowns. All right, great. So chapter 1, Introduction to iOS Programming. I'm really just looking for interact with iOS frameworks. And that's fine. Let's just get started. I just want to get started. Necessary hardware, yada, yada, yada. Okay. In this chapter, you're going to write an iOS app named Quiz. This application will show a question and then reveal the answer when the user taps a button. Tapping another button will show the user a new question. Okay. What is the secret to iOS mastery? Okay. When you're writing an iOS app, you must answer 2 basic questions. How do I get my objects created and configured properly? Example, I want a button here that says next question. Okay. Second question is, how do I make my app respond to user interaction? Okay. Most of this book is dedicated to answering these questions. As you go through this first chapter, you will probably not understand everything that you are doing, and you may feel ridiculous just going through the motions. I feel seen. But going through the motions is enough for now. Mimicry is a powerful form of learning. It is how you learn to speak, and it is how you will start iOS programming. Okay, that's a good point. As you become more capable, you will experiment and challenge yourself to do creative things on the platform. For now, go ahead and do what we show you. The details will be explained in later chapters. Creating an Xcode project. All right, so let me now split her up, get out of the way. New project. Let me add here, new project. And get rid of this one. Whoops. File, new project. A new workspace window will appear and slide down. And a new workspace window will appear and a sheet will slide down from its toolbar. At the top, find the iOS section. iOS. Okay. And then the application area. You're offered several application templates to choose from. Select single view app. God damn it. I don't have single view app, so I just assume app. Oh, weird. Yeah, I guess that used to be a thing. Make sure it's not elsewhere. Multi-platform. Okay, that's cool. My Xcode does not have the instructed app type. Single view app. would be the modern equivalent? If you're starting fresh, SwiftUI is a fantastic choice, designed for modern Apple platforms. However, if you're working, okay, you can easily create a project that mirrors the simplicity of the old single view app template. Okay. Okay, so just app. All right, makes sense. Just making sure. All right, so app. Next. The names of these templates may change with the new Xcode release. If you don't see a single view app, use the simplest sounding template. Oh. Okay, so wait, you can also, yeah, okay, I think we're okay. Enter quiz for the product name, so quiz. The organization name and identifier are required to continue. Okay, so that doesn't matter for now. Language pop-up, choose Swift. And storyboard. Choose storyboard. Okay. Well, okay, let me see that. What are the difference? I really don't, like, much like classes, I don't have any intention of using storyboard, and I don't have the issue of maybe working with old apps, like, so I don't want to spend time learning that old, ancient way of doing things, brother. Let's see. What? Well, no. Let me just see where SwiftUI starts. MVC every modeler. Actually, you know what? Since we're at 2 hours or whatever, and I'm waning a bit, I'm going to find whether it's inside this book or something else. I'm going to go to their forum and see at what point I can pick up, or if that's even, feasible. I don't know how intertwined the lessons are, but I don't see a need to learn storyboarding. I have no intention of using it, and it's dying. So, because this book is like 1.5 years old at this point, which SwiftUI hadn't had a lot of the advancements it's seen as of late. So yeah, I have no desire to learn the UI kit. Yeah, so I'm going to do that. So we'll be back tomorrow with a ready to go game plan of SwiftUI. Apologies for the jumping around, but sometimes you got to try it out. Not everything hits. It is what it is, but we'll be back tomorrow, guys, same time. And as per usual, check out my other stream, 9 p.m. Central Standard Time. Me fighting with a bunch of oily nerds on Halo, peeling back domes, baby. But other than that, guys, take care of yourselves, take care of each other. Make sure you drop a follow on whatever platform you happen to be seeing this on. And I will see you guys tomorrow.